Welcome to a lesson with Dr. Powell. Let's suppose we have an application problem that looks something like this. They give us some information like launch speed, starting angle, starting height, but they also give us an equation that represents the height of the object that's being launched. Everything else here you can ignore. Focus just on this equation here. This tells you everything you need to know about the height, the relationship between height and time of the object that's being launched. So let's suppose we have an object that's being launched according to this, where it's measured in meters, the height is measured in meters, and time is measured in seconds. And suppose we have a question that says something like this: find the maximum height that this object will attain to. So that's our question, is to find that. And maybe we also want to know when, at what value of t do we actually reach this maximum height. Maybe we even have a question that says, when will the object hit the ground? Maybe if it starts at 5 meters above the ground, when will it eventually hit the ground? Now, all the information that we need is just right here in this equation. We don't have to come up with any equation or anything, we already have it. So we just need to interpret it and see what we need to do with it. When will the object hit the ground? So that's kind of what we're after. We're just focusing on that one equation. So let's get started. Maybe first by finding the maximum height. Now, how do we do that? Well, we think of this as a parabola, and we think the vertex tells us, the what tells us a what and a where. The where is like the time, is like the x value, but in this case it'll be t, because t is like replacing x here. So the coordinate, the t coordinate, will be the time, and the y coordinate of the vertex will be that maximum height that we're after. So we just basically need to find the coordinates of the vertex of this. So let's get started. Okay, so again, we have h of t is equal to negative 4.9 t squared plus 10 root 2 times t plus 5. We're going to complete the square. So what we do is we factor out a negative 4.9, and we're left with t squared plus 10 over root 2 divided by negative 4.9 t. See what we did? I just put something down here so that when this distributes in, the negative 4.9 will cancel. And then you'll just be left with this. So always go backwards to make sure it works. Plus 5. Okay, so I did that so I could have a coefficient of 1 right here. So I can do my usual replacement with t, and then this is really, okay, well, this is really a minus up there, but basically you're just taking this coefficient and dividing it by 2. You divide it by 2, let's just think about that for a minute. Maybe I'll rewrite it as negative 10 2 negative 4.9. Or that's a plus, okay, because I put the negative on the top. Okay, so if I take a half of it, that's kind of like multiplying by half or dividing by 2. And notice that that's going to make that a 5. So really it's just going to be minus 5 root 2 over 4.9 squared, where I just took 1/2 of this coefficient and put it here as usual. And then what do I do? Remember, I always have a minus out here. What do I minus? I minus the square of this guy. So let's think about that. Take 5 root 2 over 4.9 and we square it. Okay, well, this 2 goes to everything in the multiplication and the division, because that's what exponents do. They actually represent repeated multiplication and division, and as such, they distribute across it. So doing that, we would have minus 25 times, and this is square root of 2, quantity squared, so it'll just be times 2 all over, and I'll just leave it as 4.9 squared, and I won't bother simplifying these things. I'll just leave them there, like just like that. You could simplify it, that's fine, but I'm just going to leave it there for now. One of the reasons why is because when you make decimal approximations to things, you lose over time. The rounding actually catches up with you, and your answer's a bit off, maybe like 0.1 or 0.2, 0.3 even sometimes, or more, depending on how much you round. So we get something like this, 25 times 2 on the top. Okay, so we're set to go. Then we just need to distribute this to both parts, and then we add. So we end up getting negative 4.9 times quantity t minus 502 over 4.9 squared. Negative 4.9 multiplies over here, and negative becomes positive. So we end up getting plus. Now I noticed something, maybe you don't notice it, but I noticed that 4.9 right here, you could think of it like 4.9 times 4.9. And you see this 4.9 and that 4.9, they kind of cancel right here when it multiplies. So you're left with only one of the 4.9s. And the 25 times 2 is just 50. And then I have a plus 5. Okay. So in the end, you could double check. This multiplies through, get some cancellation, but then you have a plus, and then just 50 over 4.9, you have a plus 5. This part right here is the y coordinate of the vertex, meaning it's the maximum height. This value right here is actually the time that's equal to the time that we reach our maximum height. And then we could put this into a calculator if we wanted to at this point, and we notice that right here the maximum height is approximately about 15.2 meters. So that's as high as it's going to reach. And we also notice that the time is about 1.44 seconds. All right. Now just the last part of the question was, when will it hit the ground? Well, you have your equation for height, and what is the height when you hit the ground? It's 0. If you want, you can just think about this as being h equals, and then really you're just setting this equal to 0. So you're setting this whole thing equal to 0 and you're solving. And now to do that, honestly, might be easier right here in this particular situation. So let's do that. For ease, I'm going to round here, and it will be a little bit off, but I'm not going to worry about it too much. Okay, so we're going to set this equal to 0, but I'm going to use this form. Completing the square form is nice to use when you're setting this equal to 0. And I'm going to rewrite this as negative 4.9 times t minus, and then we'll just do 1.44. It's off, but it's okay. We'll just remember that we'll be a little bit off, and this is rounded a little bit more, but let's just use it, 15.2. Okay, set this equal to 0. So basically what we're doing is we're going to isolate the square root part. In fact, why don't we just add this over, since this is positive and this is negative, so we'll just add this to the other side. 4.9 t minus 1.44 quantity squared. And honestly, this is approximate. So we'll just remember this is an approximation at this point since we rounded. 15.2. And then we can divide both sides by 4.9. So then we have t minus 1.44 quantity squared is approximately 15.2 divided by 4.9. And okay, so we get about, in this particular case, about 3.1 there. So again, we're going to be a bit off because I'm rounding a bit, but that's just for ease of following. Right now in practice, you don't round so much. You keep it out as much as possible if you want a better answer. Okay, so then we square root both sides, and we're going to plus or minus square root. And that's approximately t minus 1.44. Then you can put the 1.44 over. T is approximately 1.44 plus or minus the square root of 3.1. Okay, but remember, it's just approximate. Now, which one do we want? So plus takes us further to the right in time, and that's kind of what we want because we're kind of figuring out it's been up and then it's going down when it's hitting. And you have two intercepts, and we're really focusing on the second one. So we really want just the plus of the square root here. So it's going to be approximately about 1.44 plus square root of 3.1. All right. And so we get about 3.2 seconds. And that's about when it hits the ground. Now, I invite the viewer to actually go ahead and run these calculations without rounding. And you'll actually notice that, this is seconds. Notice the difference in calculation. So that's an exercise for the viewer, and it can be significant. In practice, I would not do this. Remember, this is approximate, and these roundings are terrible. Too much rounding. So I invite you to actually go through and don't round and you'll notice the difference. Thanks for watching.